Yes. On behalf of DYPIMS, I welcome our today's resource person, Mr. Santanu Chatterjee, sir. Also, on behalf of DYPIMS and IACSD, I welcome all the participants who join this FDP to get some knowledge on the Python and data science. So, before starting our today's FDP or today's session, let me introduce to all of you of our today's resource person, that is Mr. Santanu Chatterjee. Mr. Santanu Chatterjee has vast experience, about 20 years of work experience in IT domain. His current area of interest are data science, data analytics, machine learning, NLP, deep learning, global sensitivity analysis, and trading algorithm. Shantanu sir has successfully architected web-based solution and led teams to project completion in various domains. He has piloted infrastructure setups for server deployment, created POCs in over 10 global organizations. He has completed server virtualization and cluster setup for organizations like HDFC, LIC, Government of Bihar, T-Board, etc. He has created syllabus and course material for academic institutions as well as the industry professionals. He have trained more than 10,000 professionals in over 50 organizations in wide variety of technologies and architecture covering web system programming, web and system programming, data analysis, machine learning to server administration, security, storage, and virtualization. He has created documentation for open source software projects and question bank comprising over 2,000 questions for several organizations in the various technologies and open source enthusiastic. He has actively participated in spreading awareness about open source platform among college students and professionals since 2001. He regularly conducts webinars on FOSS technologies. So again, on behalf of IACSD and DYPIMS, I welcome our today's guest, Shantanu sir. Shantanu sir, over to you.
Sir, I'll stop my screen share.
Hello. Yeah, Keshav sir, I would like to invite you also to add some words, to say some words about our today's guest.
Yeah. Welcome all the participants. Good morning. Myself Keshav Kumar, Assistant Professor at DYPIMS. We have got two institutions. One is the Management College and one is the Technology Division. That's an ATC. That's an ACT of ATC of CDAC Acts, Authorized Training Center, Institute for Advanced Computing and Software Development. To inform you, we have participants across India and across globe. There are international people also who have joined in. Mr. Shantanu is associated with our organization since a couple of years, and he has been educating and sharing the knowledge on various technological domains like Linux, Unix, data science, BI, data mining, Python, etc., etc. So this was brief about the organization and what we do. And over to you, Mr. Shantanu. All yours. I'll stop sharing my screen so that you can start sharing your screen, Shantanu sir. Over to you, and welcome to this FDP session by Dr. D.Y. Patil Institute of Management Studies.
I request all participants, please put your mic on mute mode. Participant, please mute yourself so that we can listen carefully to our guest, today's guest, Santanu sir.
Faculties, This Keshavir once again. We are joined in by our students from Big Data Analytics course as well. So welcome to those students and our Python students as well, those who are undergoing training, and the participants and faculties from engineering and MBA. Over to you, Shantanu sir.
Hello guys, good morning. Morning everyone. It's a pleasure to interact with people. I have divided my day in more or less this 4 or 5 parts. Okay. So start with mutability and immutability, and yeah, by the way, just as an aside, the chat window will remain open. So if anyone has any question, please put it on the chat window. It will always be on the top. Any question at any point of time, okay? You don't have to wait for the question answer round, because otherwise sometimes the question may lose its relevance. Although there will be a explicit question answer round at the end, but I suggest whenever you have any question, just put it on the chat for everyone to see. And as I said, otherwise the question might lose its relevance. Okay. So we start with list and tuple, and that is how we will enter mutability and immutability. A list, as you know, is a collection of elements enclosed in a square bracket. So this is what you call a list in a square bracket, and a tuple. Some elements So a list, as you saw, is enclosed in a square bracket and tuple inside a parenthesis. Accessing elements, all of you know. Slicing. Slicing is done in this fashion. One colon 5. Now notice the elements. When you write 1 colon 5, you have the 1th element, 2th element, 3th element, and 4th element. So it does not go till 5. Okay. So when you put li1 m colon n, it is from m till n minus 1. Okay. Negative indexing is allowed. negative indexing begins from -1. No, negative indexing is allowed even in slice. You can put -1. But the calculation remains same, all right? That is just like in m colon n, I said from m till n minus 1. Just like I said till m, from m till n minus 1. Similarly over here also, n minus 1, that is -1 minus 1, that is -2. And who is the -2th element? -2th element is 9. Okay. So that calculation no, Dr. Anil Kumar. We should start with 12. 12 is the 0th element. Just like in other languages, in Python also counting begins with 0 from the left hand side. Okay. But from right hand side, it begins with -1. Cannot start with -0 because -0 and 0 are numerically same or rather equivalent, you can say. Okay. So what if you miss out the m? If you miss out the m, that means from the beginning. Okay. Now it starts with 12. And if you miss out the n, that means till the end. So to summarize over here, let me convert the cell to markdown. Li1 m colon n, when both m and n are positive, then the total number of elements will be how many? One colon -1 should return -2. Okay. See, what did I say? M colon m n means, okay, let me write it down, then you will understand. Total number of elements will be n minus m, and start with m plus 1th element, m plus 2th element till n minus 1th element. Okay. So if you are considering n minus 1th element, so if it is -1, that means -1 is -2. And who is the -2th element? -2th element is 9. So that's why it goes up to 9. Okay. Now what will happen? What will happen if n is on the right hand side? If n is on the right hand side. So I say 5:1. Python will not give an error. It will simply give quiet. Okay. It will be an empty list. So even if you are using negative index, then also you must ensure that m must be on the right hand side of n. So if you write -1:-5, once again this will give you a empty list. So if you are using negative index in both the cases, m and n, you'll have to reverse them. Now we will get some output. Now something interesting. Tuples, lists, and strings. These three are, well, we can say sequence type of collection. All right. So you can have alpha is equal to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Whatever we studied over here till now are also applicable to strings. So you can say 2:20. Okay, so it starts with the 12th element and goes till 19th element. 20 minus 1. Now, this colon thing, slicing thing, this can take a third guy. That is a second colon. Okay. So I say 1:23. Then start with 1th element and go till 23rd element. One element till 23rd element, and 23 minus 1 is 22. So whatever is the 22th element will get till there. W is the 22th element. Now notice over here, I put a third guy, colon 2, that is the second colon. Look at the effect of this guy. Notice it takes the alternate elements. So the third guy actually acts as a step. Okay. So this changes now. Let me put it as markdown. This implies mth element, m plus pth element, m plus 2pth element, once again till n minus 1. Okay. Of course, the number of elements will become different this time, but the calculation remains same. All right, that is, it will go till n-1 with a step of 2. So the second guy is step. Now something interesting. We have seen earlier that if we put something like this, we get an empty list, right? With alphas, we'll get an empty string. That's all. All right, no output as expected. Now, notice something interesting. What you can do with the second colon and the third argument. I put a -1 here. Now it puts in a reverse manner. All right, 20:2 :-1. So this will get you the string in the reverse manner. So how do I get the entire string? So this will help us in getting the entire string in reverse. So this brings us to an interesting proposition, and that is, let's say that we are interested in finding whether a string is a palindrome or not. Okay, so let's have a palindrome. Able was I, Eraitho Elba, the famous palindrome by Napoleon. So all you need to do is this. Okay. So see, brevity is the soul of bits, and Python does it extremely well, reducing short lines of codes, etc. Okay. So here something interesting. We come to mutability, immutability thing. I say li2 equal to li1 colon, and I say li3 equal to li1 colon. Sorry, just li1. Okay. Now, if I say print li1, I get this. I say print li2, and print li3. I get the same output. Then what is the difference between this and this? Well, the difference is, if you know something called shallow copy or deep copy in object-oriented parlance. This guy is a deep copy, whereas this guy is a shallow copy. Now, how do I know? The proof of the pudding is in the eating there. There is a function called ID. Okay. So I say ID of li1. notice Li1 and Li3's IDs are same. Li2's ID is different. Okay, every object in Python has an identification number. So Li2 was a deep copy. Whereas this guy, shallow copy. Clear? Now the question is, how does it affect us? How is that going to affect us? Now list is an immutable object. So I say Li1 1 equal to FG. Now notice something interesting. Notice Li3 changes, but Li2 continues to remain the same. Because when you do a colon, you are effectively creating a separate memory location. Whereas if you do equal to, that means you are not creating a separate memory location, you are simply making Li3 refer to Li1. Okay, so diagrammatic. We have a list. Okay, and I had written L1 equal to this. So then L1 is referring to this memory location. Now I say Li1 equal to Li2 equal to Li1 and Li3 equal to, in my code it is the opposite. So when I say Li3 equal to Li1, what has essentially happened is the L3 variable is created and it starts referring to the same memory location. Okay, but in this case, for Li2, I will just denote it here as L2. This creates a completely new memory location. Hence, when I am changing Li, that is when I am writing Li square bracket 1 equal to something, Li3 also changes, but Li2 remains unaffected. So be careful. It's interesting, but can be risky at times. Why does Python do that? Basically, because of a particular phenomenon which is called copy on write. Unless there is a chance of writing, don't change the location. Okay, saves memory. This is not valid for tuple. Okay, if you say tu2 equal to tu1 and tu3 equal to tu1 colon, and now you print id of tu1, id of tu2, notice all three are same. That is because tuple is, well, immutable. All right, so the slicing is, yes, it will be available, I suppose. So the slicing is creating a new memory location for the mutable guy, okay, not for the immutable guy. Just please mute your mics. Please mute your mic, everyone.
Participant, please. Participant, please don't disturb the class, please.
Okay. So that was about the list and the tuple. Now coming to something interesting on type. All of us know that creating variable in Python is very easy. We simply create the variable. No need to declare type. But does that mean that there is no type? Type is there in Python, okay? You can find out the type by writing type of X. Now, here you must understand something important. In other languages, type is associated with the variable. Here, type is not associated with the variable. Type is associated with the object. That is the fellow on the right hand side of the assignment operator. Okay. Now, how does it affect us? Well, let's say that you want to do some operation. Okay. For example, you take an input, or for that matter, enter the number. Okay. Now, since you are expecting a number, so while taking input, how does Python take the input? String. Plus str. Now, standard practice is whenever you are expecting an integer, you do this, so that you can go about doing your arithmetic operations. But what will happen if someone puts a string? We get error. So that is why we need to take precautions. Now, how do you take precaution? Very simple. You do not convert it in integer over there. Instead, you check the type. X equal to int of x. You can write a pass, do nothing. Okay, or you can give an error message. Okay. So this is where you can put it to use. All right. So precaution you can take at the very beginning. Now, when I write x equal to 2, y equal to 3.2, z equal to hello, coming to memory management, back to memory management. What happens when I write w equal to x? I rather copy this. I change the variable name to ABC. Okay. Now I say u equal to c. So what is happening now? Both of them are essentially referring to the same memory location, u equal to c. All right. So let's come to the diagram. C equal to hello and u equal to c. So I say c equal to hello. And we write u equal to c. All right. So C is essentially pointing to a memory location containing the word hello. And I write U equal to C. So now U is also referring to the same memory location. So how many guys are pointing to hello right now? There are 2. Now I write U equal to high. I write U equal to high. So what happens then? Does C change? Question is, will C change? How many of you think that C will change? How many of you think C will change? Okay. So I write U equal to high. C doesn't change. C continue to remain hello. Why? Because Python has something called a reference semantics. So what will happen now is it will create a new memory location with high, and then it will make you refer to the new memory location. C continues to be whatever it was. So now how many guys are referring to hello? How many guys are referring to hello? Only C, 1. Now I write over here C equal to U. So what happens now? Now this is gone, and C also starts referring to high. The question now is what happens to hello? Well, hello then remains in the memory with a reference count of 0. And here garbage collection comes into the picture. Hello becomes a garbage, and it will be collected by the garbage collector. Okay, Python's garbage collector works pretty well. Yes, there was issue with Python. There were issues with Python garbage collector once upon a time long ago when I studied Python for the first time. But now it works pretty well. Now coming back to list again. List has certain inbuilt function. Remember, Python is an object-oriented programming language, implying that everything we studied over here is an object. And since everything is an object, objects have methods and attributes. So how do we figure out the methods and attributes of any object in Python? Actually, there are two things you need to remember in Python, all right, other than the syntax, of course. One is how to find out what are the functionalities associated with the object. So how do we find that out? li1 is an object, right? li1 is a list, and list is an object. So how do I find out what are the functionalities associated with the object, or what are the functions that you can call using an object? You know that objects can call their functions using the dot operator, right? All objects will call their functions with the dot operator. Object dot function name, object dot function name. So the question is, how do I find out what are the functionalities available with the object? Anyone? Okay. It is the dir function, okay? And if you use the dir function, it will give you the list of functionalities associated with the object. You can skip the underscore thing for now. They have special meanings. The non-underscore things, they are the functionalities associated with the object. Now, how do you know how to find what a function does? Very simple. All you do is object dot. If you press a tab, you get a drop down. Okay. My laptop is slow. So I will write. Let's say extend. So this is how you find out what a function does. Okay. Object dot function dot double underscore dot double underscore. So these are the two things basically you need to remember in Python. One is the dir function and one is the doc attribute. Okay. How doc is created is part of documentation string. Is part of functions. Okay. So li1 dot extend dot underscore underscore doc underscore underscore, that will give us the capabilities of the extend function. So remember these two things: dir to figure out the functions associated with an object, and object dot function name dot double underscore doc double underscore to find out what the function does. Now, if you remember, we had created two guys, li2 and li3 from li1. Okay, I will re-execute li1. Okay. And I will re-execute the li2 and li3 because I had changed li2 somewhere midway. I don't want any confusion. Yeah. So li2 equal to, sorry, let me just write the what is there in li1. I hope all of you are convinced that all three are same right now. But still, as a precautionary measure, I just. Yeah, print li2 and li3. So all three will remain same right now. Now, consider the function extend. I tried on another list. I said new li equal to 1, 2, 3. And I say new li dot extend four, 5. Now if I say print new li, it will have 1, 2, 3, 4, 5. Now I could have done the same thing by writing concatenation. So now the question is, what is the difference between this operation and this operation? Anyone? Both are giving me the same result. Anyone? What is the fundamental difference between these two operations, that is dot extend and new li equal to new li plus 4, 5? Anyone has any input on this? In both the cases, it happens. In both the cases, the size increases. In this case, also size increases. In this case, also size increases. Okay. Let's get back to IT. Notice the ID remains same. Okay. The ID remains same when I do an extend. But sorry, extremely sorry. I am making a mistake. I should have written new li. I fell back to new li. I fell back to my favorite variable, and that is li1. Okay, now notice. After doing an extend, the ID of new li remains same. All right. But after doing plus, the ID changes. So understood. What is the difference between dot extend and plus concatenation? When I am doing concatenation, I am essentially creating a new memory location. All right. So coming back to our this board. Okay, let me create a new board. When I am writing, I just write NL. Okay. So when I am writing NL dot extend, what is happening is this. In the same memory location, it will add the elements. But if I am doing NL equal to NL plus sorry, 4,5. Then what is happening? A new memory location is created. Okay. So we had 1, 2, 3. NL referring to this. After I do NL equal to NL plus 4, 5, what is happening is a new memory location is created. This gets destroyed. And this starts referring to the new location. So what happens to 1, 2, 3? Is anyone referring right now to 1, 2, 3? Is anyone referring right now to 1, 2, 3? No. So that means it becomes a garbage. Okay, and it will be deleted by the garbage collection. Now coming back to our L1, L2, L3. Let's add some more spice to life. We had the L1, L2, L3. All of them referring to the same all of them having the same value. So Li2, as we know, refers to a different location. So I say Li1 dot extend I say li1 dot extend 50, 60. Now the question is who changes? li2 changes or li3 changes or no one changes or both changes? Please remember li3 equal to li3 I had written as li1 colon. li3 was a deep copy. Sorry, li3 was a shallow copy. li2 was a deep copy. Okay. Now, if I write li1 dot extend something something, who changes? li2 changes or li3 changes? li1 will obviously change. Fine. So li3 changes, okay, because li3 was referring to li1's memory location. li2 was, of course, a deep copy. Now, another question. Let me re-execute those li1, li2, and li3. I execute li1. And then I execute this. Right now, both are same. Okay. Now I say li1 equal to li1 plus now tell me who changes? li2 changes or li3 changes or no one changes or both of them changes? What do you think? Who will change this time? li1 will change, sorry, li2 will change or li3 will change or both will change or no one will change? li1 will always change because the operation is on li1. What about li2 and li3? Who will change? li2 changes or li3 changes or both changes or no one changes? Okay, some people are saying li3 and some people are saying no one. So the conflict is between those two. Okay, so, well, the truth is no one changes. li1's memory location itself changes. So li2 continues to refer to the old memory location and li3 continues to refer to the old memory location and li2 was anyway different from the beginning. Okay, so no one changes this time. So that is the difference between mutable objects and immutable objects. All right. With the list which happens to be a mutable object, lots of functionalities, and you can do a shallow copy and deep copy. Now a question from dictionary point of view. I say my D1 A:1, comma B:2. Okay. I say my D2 equal to my D1. Then I say my D1 A equal to 3. All right. Will my D2 change? Will my D2 change? Yes, my D2 will also change, because once again the same reference semantics comes into the picture. Then how do we do a deep copy of other objects? For list it was simple. I just put a colon and it makes a copy. For other objects, how do I make a deep copy? So we have a particular module for that. So I say my D1 equal to this. I re-executed that. My D3 equal to deep copy. My D1 equal to 3. My D3 does not changes. Okay. So make use of this from copy import deep copy whenever you have to make a deep copy of any other object other than a list. List we saw is very simple. You just put a colon and you get the copy of the entire list. Clear? All right. Next, what did you say was in our agenda? Functions. Well, actually, functions are also first-class objects in Python. Instead of my fun, let's say RDT. I can simply give a call to it. Easy enough and cool. What if the function does not return anything? For example, the extend function. Its job was to extend the list, not to return. We can have functions that just does something. How do you call this function? Look what happens. I get the output and I get an additional none. Why? Anybody can throw any light on this none? No one? Returns nothing. So how do I call this guy? Right. It returns nothing. Correct. If you do not write a return statement explicitly, Python will default to something called none. None is something like void in other programming languages. Void or nil or null, whatever you call it. Okay. Python doesn't shout an error. So how do you call such a function which does not return anything? You cannot call such a function with print or as an R value. R value means something equal to printed. You simply invoke the function. Okay. Do not call it with print, otherwise it will print none. In functions, you have those capabilities of keyword function and no, return over here is none. Okay, return is not void. There is no void in Python. Okay, the return value by default to none. By the way, none evaluates to false. In Boolean term, none will evaluate to false. So if you use such a function in if condition, it will evaluate to false. It will not evaluate to true. Okay. Now, in Python, there are different categories of functions. For example, you can have default value, and you can have what do you say, keyword functions. So, in case of default value, you can write x equal to 3, y equal to 4. And then you can simply call the function without any argument. You will take the 3 and 4 as the default value. Oh, sorry, I forgot to execute. Yeah, now I can. It will execute with the default value. There is a restriction on this. If you have multiple arguments, this is allowed. Okay, then you have to pass an argument over here, which will replace x. That means you have to pass one argument to this guy. Okay, but this is not allowed. Okay, non-default argument follows default argument, error. So if you are mixing default as well as non-default, then you must ensure that the default value must be after the non-default guy. Okay, that is one thing you need to take care of. Now consider a scenario So who gets what? X gets 5, Y gets 2, sorry, Y gets 6, and Z continues to be at 9. If I pass one argument, it will replace the first guy. Okay. So 18 plus 2 is 20, 20 minus 9 is 11. All very fine. What is it that we cannot do over here? What is it that we cannot do over here? See, if I pass two arguments, it replaces X and Y. If I pass one argument, it will replace X. If I pass all three, it will replace X, Y, Z. So what exactly is it that we cannot do over here? Any operation which we cannot perform in this case? That is an error. That is an error. That is out of question. I am asking while calling the function. I am giving you a hint. More than 3 arguments, of course, we cannot pass more than 3 arguments. We cannot pass more than 3 arguments because there are 3 arguments over here. We are interested in 3 arguments only. Consider this notepad. Okay, when this notepad is launched, it comes with certain properties, right? For example, background color, foreground color, font size, font type, right? It comes with all these capabilities. So typically these things are used in GUI programming, all right? Where while creating a GUI, you put default values. So otherwise, what will happen? Every time it launches the notepad, it will ask you what do you want the foreground color to be, what do you want the background color to be, what do you want the font size, what do you want the font type. All these things it will start asking you. You don't want that for the user. So you put some default values. That is typically how GUI programming is done. Okay. Cannot change just Y or Z. Very good. Cannot arbitrarily change Y or Z. We have to go sequentially. And that is precisely where Python provides us with a capability called keyword arguments. In keyword argument capabilities gives us the power to change any one of the values. I can simply write here Y equal to 25. Okay. And it increases readability also in your code. In large functions, which takes, let's say, 15, 20 parameters, it increases readability. Remember, readability counts. All right. So this is the concept of keyword argument. All right. In keyword argument, you can actually call by the name of the formal parameters. So effectively that means that the formal parameters actually exist. Unlike other languages where formal parameters actually do not matter. But here the formal parameters name actually exists in the stack. All right. So that is markedly different from what other languages provide us with. Now, how do you pass variable number of arguments? It's very simple. Actually, someone has already written over here. You just say star R. So this will simply pass any number of argument. Okay, they are stored in a tuple, the arguments. Now the question is, how do you pass variable number of keyword arguments? That is also pretty simple. All you need to do is now here also remember something important. When you are using keyword with non-keyword argument, when you are using keyword with non-keyword argument, I can simply create this function a comma b comma c, print c, return a plus b. Okay, and I can use this print kwr of a equal to 5 comma b equal to 6 comma c equal to hello. I can do it like this, or I can directly pass hello. I can even keep mentioning the arguments. Okay. Now, what is it that I cannot do here? I can also mix here. I can write a equal to just 5, then c equal to hello, b equal to 6. Allowed. What is not allowed is this. All right. Positional argument follows keyword argument. So just like the previous case of default value, here we are not allowed to put positional argument after the keyword argument. Keyword arguments must be always after the positional arguments. Okay, or you can explicitly put all three simultaneously. Where cares? No. In order to put arbitrary number of default arguments, you can of course write, then the first one will be taken by the first guy. Allowed. It is KR, sorry. So if you pass to this default as well as keyword as well as positional, comma z equal to y equal to 9 comma z equal to 5. So keyword arguments are still stored in tuple. Sorry, non-keyword arguments, that is positional parameters, are still stored in tuple. Keyword arguments are stored in y:9, z:5. Now there is a question that what if we write r comma this? Okay, very simple. 5 will be passed on to r. Okay. It is not an error, no problem. Just that 6 will come to star r's. Everything till you put non-keyword will be taken by star r. All right. So you can always put ordinary parameter along with the variable number of argument. Now do not confuse the star and star with whatever you studied earlier. Okay. All right. Now something interesting. I say a equal to 5. Def my func oh, why do that? All right. Let's say we come back to our add. Get back to our or my calc x comma y. X equal to 5 into x plus 6 into y, or 6 divided by y. Y equal to 3 into y minus 4 divided by x. Okay. Return x plus y. Note this code. Now I put v1 comma v2 equal to 10 comma 20. Okay. And I write my calc v1 comma v2 print. Now the question is, who gets v1? Who gets v1? X will get v1, right? And y will get v2. Question is, will v1 v2 change? Will they change? Okay, they won't change, all right. Now, what I do is, instead of writing v1 and v2 here, I put them on top of the function. So V1, V2 does not change. What if I do this? What if I do this? Now will V1, V2 change? Well, V1, V2 will still not change, okay? They will continue to be whatever it was. All right. Now, there is a special keyword called global. Now see. V1 changes, but V2 continues to remain same. So when you put global inside a function, then Python will not create a local variable. All right. It will continue to work with the global V1. Otherwise, Python will always create its own variable in the current scope. All right. Now a question might arise that where do you use such global things in real life? Well, actually, they're used in frameworks, large frameworks. All right. See, every time you try to log in with username password, everyone does not have a database login in the server. You have an application login. The database login is only one. Okay. Or when you are working with a global file handler or global database handler, that is when you take the help of globals. Otherwise, under ordinary circumstances, they typically try to avoid globals. Okay. Now something interesting about functions. Well, in mathematics, just a minute. Yeah. Let me increase the font. In mathematics, you write x equal to 2. You write y equal to x. In fact, the whole of mathematics can be considered to be this variable equal to value. You can make the value a little bit more complicated with, let's say, exponential of x plus sine of x square. You can do all these fantastic things. But eventually, it is variable equal to value. Now the question is, if I write this, how do you define f? Can I write f equal to something? Or rather, in this case, who is the variable and who is the value? who is the variable and who is the value. In case of fx equal to x square plus 5x plus 6, who is the variable and who is the value? Anyone? Okay, x is variable, fx is value. Fx is value and x is variable. F is variable. Variable is x. X is value. Now this is really confusing. So one guy named Alonzo Church, he wanted to integrate mathematics. That is, whole of mathematics he wanted to be as variable equal to value. And hence, he brought a new notation and gave that notation lambda. He said that f is the variable and we can actually write f equal to lambda of x arrow this. All right. And he brought an entire branch of mathematics on this. As opposed to axiomatic mathematics, we get type theory based mathematics. Okay. Now in keyboard, you really don't have any lambda here. So Python provides us with a lambda keyword. So you can write square equal to lambda of x colon x into x. And you can pass this guy to this. Okay. Understood? What do we achieve by this? What have we achieved? So square now becomes an ordinary variable. Square right now becomes an ordinary variable. And we can pass it as an argument to another function. Okay, colon is just a replacement for this arrow. In mathematics, this is the syntax. In mathematics, this is the syntax. In Python, if you have to write it, you will write lambda of x colon this. Okay. So this is a direct translation from mathematical to Python. So an example, a real world. We know that, this, what is the name of this browser? One is Google Chrome and another is Mozilla also goes for HTTPS. This other browser, Edge, Microsoft Edge or Microsoft Explorer. Yeah, they do not go for HTTPS, they go for HTTP. All right. So I say create URL. I said def apply. Sorry. Q comma X. def apply, well, URL. Return lambda x colon, or let me give it a proper name, proto colon proto plus URL. All right. Now I say Internet Explorer equal to apply. It should be URL plus code. Or rather, I change this name. I call this proto. I call this URL. Although Shakespeare had said what's in a name, but names matter a lot in programming, especially variable names. And Chrome equal to apply. Okay. So this guy can now act as a function generator. If you have an FTP browser, you can create an FTP browser with apply FTP colon // So what do I get in return? What I get is I really do not need the help of if else anymore. Remember, programming logic is the place where maximum bug occurs. So the lesser number of logic you try to implement, lesser are the amount of bugs in a program. So this helps us in eradicating if else. I do not have to write if this, if this, if this. We can have any number of protocols over here. Okay. My bad. I should have here I made a mistake. It should be proto plus URL. Sorry. Okay. So as you can understand that we do not need to put the if else continually over here. We can go about with this. Now, this type of functions which can take another function as an argument are typically called higher order functions. All right. Now, lambda calculus in itself is a huge topic. In fact, Python also gives lots of capabilities for lambda, especially the two functions map and filter. We extensively use them using lambda. One very simple example that we can think of is, let us say, let's say two set of marks. What is happening? Oh, sorry. This somehow became a markdown cell, I think. Yeah. Sem2 equal to 15, 19, 7, 16. Now, how do I add the corresponding elements? How do I add the corresponding elements? One way is to use for loop. Okay. A far simpler way is given by map. You use extensively lambda over here. I forgot a parenthesis. Yeah. Okay. Remember, if we just did sem1 plus sem2, that will be concatenation. Okay. If we just put sem1 and sem2, sem1 plus sem2, it will be concatenation. What we required was a way to add up the corresponding elements. Okay, that is 12 plus 15, 15 plus 19, 9 plus 7, etc., etc. All right. And what we got over here is the corresponding addition. All right. Similarly, if you use the let's say you want to, there is a corresponding function called filter. So let's say you have URLs a.in, b.jp, c.in. I want to filter out all the guys that ends in in. That is the Indian URLs. So no need to use your for loop and other juggleries. You filter out using a lambda. X dot ends with in, comma, URLs. Okay, so as you can understand that these functions using lambda, you can effectively eradicate the need for loop, if, else, all those fantastic things. All right. So, and you know that lesser the for loops and if, else and stuffs, for loops, if, else, and all these stuffs, the lesser are the chances of bugs in your program, because most of the bugs in your program occurs in for loop, while loop, if, else, all these places. And it also reduces the number of lines of code. All right, if you know how to use judiciously use lambda and these higher order functions like map and filter, it will be far easier for you to arrange for that. Okay. All right, guys, I think I have spoken enough on these elementary topics. Take as an assignment this. We saw how to do that. Abdul was ere I saw Elba, right? Now in this palindrome, this was a very simple-minded palindrome. But look at this one. if you notice carefully, this is also a palindrome. A man, a plan, a canal, Panama. Take this as an assignment. How do you manage this palindrome? How do you manage such a palindrome? Think about it. Okay, and please try to arrange for and try not to use for loop, if else, all those fantastic things. Okay, try to do it with without those things. Try to do it with filter and map and stuffs. Okay, all right. Any question? Any question about this? Whatever you learned today about management, memory management, and what else? The functionalities and other stuffs. Otherwise, I think we should wind up. All of you are hungry also, and this is Sunday. Yeah, I request Mr. Keshav and others people to please share with you guys the feedback form.
Yeah. Thank you, Mr. Shantanu. Chetan?
Yes, sir. Sir, I have
Okay,
shared the link, feedback link.
So
I have
please,
shared the feedback link. All participants are requested to fill the feedback link so that once we get your feedback, we'll issue the certificate against your feedback. Okay. So feedback is mandatory for all the participants who attended today's session, so that we come to know about your experience about today's session, so that in upcoming FDP, so we can, if any suggestions are there, if anything you would like to learn more, any new topic, then accordingly we can arrange the FDPs, and it will help us to improve our process. So all participants are requested.
People have not yet received the feedback link. I think just share it on the chat box once again.
Chetan will put it on the chat box once again.
Yeah, please.
It was really nice and quite
Thank you everyone
explainable
for
session, and some of the logics concepts were explained properly. I thank Mr. Shantanu and our participants for listening, and Mr. Shantanu for delivering such a wonderful session. On behalf of DYPIMS, I would like to thank all, and also to all the participants. DY Patil Institute of Management Studies is under Savitribai Phule University, offering management courses in specialization in marketing, finance, HR, as well as analytics. Also, we are NAC A grade institute, and a couple of more things Chetan would add to that, my colleague. Chetan, are you there? Chetan, are you there? believe we have lost him.
Yeah, seems so.
Not an issue. I am just putting the feedback link once again
Yes,
for
please.
all the
Yes,
participants.
so feedback link is here, guys.
Once again.
Please put your feedbacks.
You're there.
Am I audible?
Yes, yes, you are audible.
Now audible, no?
Yes, yes, now you are audible.
Okay. I, Chetan Khairnar, Assistant Professor of DYPIMS, would like to thank our today's guest, Santanu sir, for delivering the beautiful session on Python with data science. And I will also like to thank all our national, international participants who participated in today's FDP. In near future, definitely we are going to arrange a few more sessions on Python and related technologies. So we request all the participants to do participate in our upcoming FDPs so that we will continue this series. We will have a good knowledge sharing session on Python as well as the business analytics kind of technologies. So again, on behalf of DYPIMS and IACSD, I thank to our today's guest, Santanu sir, and all the participants. Thank you so much.
Mr. Shantanu, any few you would like to say anything, or anyone has any question, doubts? We still have a couple of minutes. You can ask. Feel free.
Yes.
Then we'll conclude the meeting session. FDP session.
The forum is open for question answer. So any question from participant side is always welcome.
Okay, guys, I think that's all. It's Sunday also, so people are hungry already. So let's wind up. Thank you everyone for attending the session.
Thank you. Thank you all the participants, Mr. Shantanu, Mr. Chetan. Thank you. So we'll wind up.
Yeah.
Thank you, sir. Santanu sir, thank you. Thank you, Keshav sir.
Thank you very much, sir.